Okay, hi, I am Matteo. This is my presentation for, for the exam case study for the certification of Advanced Data Science with IBM. Before I start, I want to apologize for any spelling error, as English is not my main language. Having said that, we can begin, and for the analysis of my study, I've used IBM Watson Studio, in which I've done the analysis and the model selection, the model preparation, and the model evaluation. I've used in this case study, I've used several standard packages for the analysis and the construction of machine learning models, such as Pandas, NumPy, Seaborn for visualization, and scikit-learn and Keras for modeling. The objects of the study chosen concern the analysis and the construction of a model on a dataset taken from Kaggle, one of the main platforms that provides datasets for studies and competition. The dataset chosen concerned the tourism in Tanzania. In particular, we wanted to find a model that categorizes, according to the features, the cost class of each tourist. As you can see here, I have the table, and for each row, since this is a supervised machine learning problem, we have a cost category, and we want to be able to have a model that can predict our label target, variable target, with all these attributes, given all these attributes. Okay, so now we can start. Now, as the first part of each machine learning problem, we have to identify the kind of problem, and this is obviously a categorization problem. And it's also a supervised machine learning problem, because the target variable is given. This is the cost category, and it's provided in the dataset. Having defined this as a starting point, I then proceed to an exploratory data analysis of the main characteristic of my dataset. Here I've seen that each of my feature have the right type of attribute. As we can see, there are a lot of objects, so a lot of strings that needs to be transformed into categorical variable, or the ones that are Boolean needs to be transformed into 1 and 0s. Okay, we have seen also that there are 18,000 observations. Subsequently, I have grouped all of my features in order to see that there are some in order to have a grasp of my dataset. So I have identified, for example, here the presence of some null values, especially in travel with feature, which then I will fill with the most recurring value. So I will impute the most recurring value in the subsequent part of my job, of my model preparation. Then I have also explored the categorical feature, and for example, I've observed that there are a lot of countries that have only one observation in my dataset, thanks to the function value counts of pandas. I've managed to see that some countries have a lot of entries, while some others have less. Actually, have just one, and maybe they are irrelevant to the model as they are. So in the future, in my model preparation, I will group them into one big bucket, which will be other country. Then I've done some more of some other analysis on the numerical part. So this is a bit. This is just an observation of what's the mean, the maximum, the mean, the standard deviation, the minimum, and I've done some visualization of the outliers and of the distribution itself with some box plots. As we can see, we have some outliers, which I will then, in my data preparation, shrink them down to the max value. And then I've done some more of exploratory data analysis with some other graph. I've seen, for example, in these graphs, I've seen that as someone could expect, tourists that came from a country that is richer than others have higher costs are categorized as higher costs in conversely to differently to tourists that came from poorer country. They belong to, most of them belong to lower cost category, while those who came from richer country tend to be categorized into an higher class of our target variable. Now, I've done some other exploration. For example, this also was to be expected that the older the tourist is, the more likely is to have an higher cost of category, to be classified as higher cost, for the reason that an older person is most likely to have more money, and so it can easily spend those money on travel and being a tourist. As we can see, the younger you are, and it's more likely to be classified as lower cost of tourist. That said, also there is another observation that we can make also to the kind of tour arrangement, if it is part of a package tour or if the tour is independent. And as is to be expected, if you are a tourist that comes independently, you are most likely to be categorized as in the lower classes, so lower cost, low cost, lower cost, and normal cost. But if you came into Tanzania with a package tour, you are most likely to be categorized into high cost, higher cost, and higher cost. Now, having done all these analysis, we can pass to our model. Selection and evaluation. I have imported my libraries. I have imported again the dataset from into IBM Studio. Then I have divided into the kind of columns. Then I dropped the useless column, which is the ID. I've imputed all the missing values. I've then I've done all the transformations, so transform the boolean into integer, transform the object type into categorical type, and then I had proceeded into make a one-not encoding. But before that, I have showed that I've, as I said, group all of these of this country that have lower than 50 entries into a one big bucket called others. So we can see that, for example, in here now, other, it is a bigger bucket, and so the machine learning model can easier grasp with those values, because just one entry on each of this country wouldn't count much on for the model. But in this case, having grouped them, it could be of use. I've done the same thing, as I said, with the outlier. I have shrunk the outlier to the maximum limit out of which they became outlier. Then, as I said, I've transformed all of my features that are categorical into categories, and then I have done the 1 coding. And yes, having said the 1 coding, then I've transformed them to floats, only to have just one type. Let's see, cohesion of the type of my. This is not necessary. This is not a part that is necessary, because once they are 1 coded, they could be easily sent to the model. But I prefer also to make them everybody of the same type, except for my target for my target label, which is this one, my target column, this one, cost category. Then I have I've done some other scaling, like standard scaling and normalization scaling. But before that, I have split the data into train and test, and then I've proceeded with my model search. For start, I've chosen the metric F1 weighted, because we have multiple classes. We have 6 classes, and I think that F1 weighted give us good metrics on the model performance, on all the classes, and all the capacity to generalize to all the classes of my model. So I've started my model search, creating just empty models. By empty, I mean without any other parameter specified, so as they are by default. And I've seen them, and I evaluate the result, and for each of this kind of model, SVC, logistic regression, I've seen the result with the default model. I've seen the result for the not processed dataset, for the standardized and the normalized data. Sorry, and I've done this with the SVC and logistic regression, decision tree, KNN. Then I proceeded to do the same with some ensemble models, so random forest classified, which yields the best results, as we can see, 0.75, so 75% of F1 score. Then gradient boost classifier, voting classifier, and then also with XG boost. I've then proceeded with some hyperparameter tuning, as I've seen that XG boost and random forest yields the best results, and I've decided to proceed with both of them and try to enhance this score with some hyperparameter tuning, and I've decided to use both the random search on the random forest and the grid search, and similarly on XG boost. But as I've discovered, it takes a long time, so I've made run. So this will be some long running cells. But at the end of all my studies, I've discovered that the best model is is the one discovered with the random forest, the random search, sorry. And it's the random forest model with this kind of hyperparameter, which yields the results on the test dataset of 0.75. And then I've proceeded to do the creation of a model, which is a neural network model. I've used Keras API of TensorFlow, and I've also had to build my own F1 metric, because as we all know, Keras, when the model is to compile, needs to have a metric, but there is no F1 weighted metric inside the standard libraries of Keras, so I had to build my own. And I had to also have the dummies of my target variable, because otherwise the neural network wouldn't work. So I transformed my target variable into I have a one not encoded, sorry, my target variable, and I've then created my neural network. It's a sequential neural network with various dense layer, sorry. And for each layer I've used a dropout of 0.2 in order to avoid overfitting. Of course, the activation is ReLU, except for the last one, which is softmax, which is used softmax to divide into the six class of my cost category target variable. Use, of course, as a loss function category across sector, and then I have fitted a model on 50 with 50 epochs. At the end of all these epochs, I have a score which is slightly better, of 0.751, sorry, and this is a mistake which I am now to correct. I need to correct this. Only 0.751, and as I said, I've decided to use the F1 score because I think it's a good balance between precision and recall, and since the classes are also not well balanced, I prefer to use this one as the to use them as a metric for the evaluation of my model. Pardon if I have stuttered a bit. And yep, what else can we add? I can think about 2 or 3 ways that we can improve all of this work that we had done. For example, we could have done some more feature engineering. Some more feature engineering could be done to improve further the performance of a model. And this feature engineering specifically is about the countries, for example, that we can group them into continents, because as you can remember, we have grouped all of those entries which do not have a lot of entries, all of those countries which do not have a lot of entries. But in these big buckets, which is others, there are people that comes from different regions of the world, and maybe it would be best if they are put into different category based on the country and based on the continent, sorry. And this is one of the way we can improve our model. Or we could have grouped them by similar economic and cultural country that or we can as I said, put them into similar countries, or we can divide it into, we can put them into continents, or we can put those entries, those countries which have low number of entry into similar countries on the economic and cultural profile. We could also have done some other feature engineering, like create a new maybe we can pass here and let you see something more. As you can see in the dataset, there are a lot of Boolean and of the people that of the kind of package that they've chosen to take. Maybe we could have also created another column here, which it is the sum of the package that they have taken, and that could also be some kind of metric, of an helpful metric for the model. And I think that would be a good estimator of the cost class, because if a person has taken a lot of package, it means that they are likely to be into a higher cost category. These are the improvements that we can make to our model. Having said that, I am pretty happy with the performance, and I hope I have met your expectation. Once again, pardon for my English, and next time I will be better. I hope we can chat again and speak again. And yes, pardon for my English. I hope I have met your expectation. I thank IBM and Romeo for the lesson and the course. I hope to have happy news about this exam soon, and have a good day, and bye bye. Thank you very much for the lesson.